like this than I am. There we go. Okay, we're now recording. Thanks, Taro, and apologies for the interruption.
No, no, not at all. And I am keeping my eye on the chat screen. So and if you have anything, please just come and interject. So and let's talk about the net zero and for start. So and when you talk about the net zero, and maybe many of you are already aware of this, but and the underlying assumption behind it is not always very clear. So suppose that you have got one cow here, and suppose that we have to achieve net zero. Then all you have to do is to plant a little bit of tree. And if the little bit of a tree, the area is disproportionately large compared to the number of animals, then you can always achieve net zero, because the greenhouse gas emissions from this animal will always be offset by the carbon sequestered by this tree. Our very simplified modeling suggests that if you have got one beef cow or above beef cattle, then if you have got about the half a hectare of the forest of any kind, it is sorry, the minimum amount of the area required is about the half a hectare. But if you are able to provide that, if you are able to match that, then you can always achieve net zero. But this discussion is absolutely meaningless, because our purpose of life is not to achieve net zero, full stop. Our purpose of life is to provide food to the whole population, to have meaningful life, and then whilst doing so, achieve net zero. When we say we will achieve net zero, it is not always said, but it is always implied that we will do so without incurring negative social consequences on many, many things. For example, economy, food security, health, environment, ecology, and many, many more. The point again is that to achieve net zero full stop is a very, very easy thing to do. In an extreme case, if we shut down all the agriculture, we have got net zero agriculture. But that means absolutely nothing. But when you discuss net zero, you really don't have a lot of understanding, or at least the agreed assumption about what is this implicit assumption that we are having a debate on or upon. And so and this is the one of the most important points you have to think about when you carry out net zero debate, any net zero debate. Are we talking about the achieving net zero without reducing any food security, without reducing any environment, without having any macroeconomic impact, and so on, so on? So and you may be aware of this work from Rosenstedt, that while Michael and I were both there, and we ran the simulation analysis to have what kind of the impact we will have if we have the meat tax in the UK in a similar manner to the sugar tax for the drinks. And our assumption was that we impose the tax at about 18%, as suggested by the Oxford team. And our modeling results suggest that if you do that, you indeed can achieve a large amount of the greenhouse gas savings, equivalent to about 2.5 megatons per year. In so doing, you can have, depending on the what carbon credit carbon market value you apply, we estimated that the environmental value of doing so would amount to about the 100 million pounds per year. At the same time, though, that we estimated that the negative macroeconomic impact of this taxation would be about 2.5 times greater than the monetized benefit on the environment. And therefore, if you impose the meat tax, the chances are, purely on the economic term, we are worse off compared to nothing happens, or the status quo. Again, this is the question of the and at what cost we want to achieve net zero. if your take is that the climate change is more important than anything else in the world, we have to achieve net zero at any cost, even if the economy is shut down, then whether the ratio is 1 to 2.5 or 1 to 10 or 1 to 1, it doesn't matter because you have to do that at any cost. But if you'd like to have a balanced growth pathways, whereby you balance this environmental sustainability with other goals of the society, then you have to also think about all these repercussions. So that was the problem we wanted to raise. Which is the right point is a policy question, and the science doesn't touch that in general. But we wanted to provide this data so that you can have better informed the discussion about the zero policy. And the second example, which I'm sure have seen before, is about the nuanced narrative around the carbon footprint. This is the comparison of the livestock farming systems in terms of the short-term impact of the carbon footprint. And we are looking here at the metric of the carbon footprint per nutrient score. So on how much of the macronutrient and the micronutrient you are able to get from that farming system. And compared to the more conventional metric of the carbon footprint per gram of meat or the gram of protein, we have found that the beef system and lamb system, especially beef system, has got the relatively lower carbon footprint because they provide more of the micronutrients compared to the monogastric counterparts. However, it does not show that the ruminant system from the outdoor outperform the monogastric system purely based on the carbon footprint, because even though the nutrient composition is probably superior, and the carbon footprint is still higher thanks to the methane emissions from the enteric fermentation. On the other hand, if you look at the long-term impact on society, including the land use change or the potential land use change across the nation and beyond, then you look at the metrics of the arable land use, how much land in addition to grassland you need to provide the nutrient to the human beings. We found that the lamb system actually is the more superior system, and the beef system is also superior to the monogastric system. So again, the point here is about the target that we need to set for society and what we are trying to achieve. Without knowing what we are trying to achieve, and you really don't know what we have to do in terms of the changes in the farming systems. Again, if you are able to import all the food from overseas, then yes, you can shut it down. But then you will have the macroeconomic impact because you'll have the deficit in foreign currency. The forage beef still has quite a lot of cereals, and hence the higher carbon score than cereal beef, and the fact that there is any arable land use for the forage beef. So the forage beef system here assumes that it is largely grazing based, and even during the winter, and we use the domestically homegrown silage. So the reason why the carbon footprint is higher is purely because of the, not purely, sorry, but primarily because of the lower digestibility of the silage when you take the average values. And the arable land use here is yes, the supplements during the winter, and how much of that you cannot really convert easily from the grassland. And that requires some assumptions, of course, and what kind of soil fertilities you're talking about, what kind of drainage you're talking about, which I'll mention in a minute. But it is largely a grass-based system we are talking about here. This is my final piece of work that I'm going to discuss from Rosenstedt of the non-livestock trial, or colloquially known as the vegan trial at Noswick. And so what we wanted to test there was that we wanted to see whether we can have plant-based farming systems in the conventionally grassland in the middle of Devonshire, or anywhere really, where grassland systems are currently the dominated system. And so what we wanted to see here is that we convert the grassland, the typical grazing land or the silage production area, to the arable agriculture, and see what kind of unintended consequences may arise from these. So and so this is quite a surreal landscape we had got in Devon, whereby we have got the very conventional grassland with some the arable crops growing in the middle. In running this trial, we set some rules to really look into the future or lack thereof of the land transformation. In so doing, we decided that we will apply no manure to the arable systems, because we are assuming the world without livestock or very few livestock. We did not have any feed crops as part of rotation, because we are thinking about the world without livestock. And when you actually look into the data of all the arable farms in Midland, and very few farms use the rotation without any feed crop as the breaking crops. So this itself was the challenge for us. And then as a slightly light-hearted rule, we decided not to wear a jumper, because we are thinking about the world without sheep. And we could not use the boots, because we were thinking about the world without the cattle skin. But more seriously, when you look into the arable land, and there have been many crop models showing how much of the alternative proteins could be produced in currently grassland areas. What they don't look at is how practical it is to convert this land in terms of machinery, in terms of the processing, and so on. So in the process of the conversion, yes, I will show a little bit of that in a few minutes. But the full results are not yet collected there. Even if biologically you are able to have the alternative protein systems or the alternative series systems, there are many places, as you know, or as you are fully aware from as grassland farmers, you cannot sow, you cannot spray, you cannot fertilize, you cannot boost to put the protein value up, or you cannot harvest. At one stage, we had got more than a 3-week window between the biological maturity of wheat crop to the when the tractor was able to go on. And in the current debate about how to transform land, these practical issues are not really considered at all. And then so again, we wanted to raise awareness that it is not just a case of the computer model showing that you can grow this crop, and this crop here, because there are so many things that the only people who are familiar with agricultural systems and can identify. And if this comes from food consumers, urban-based food consumers, then these things are very often overlooked. In terms of the carbon, nitrogen, phosphorus, and soil losses, and this video you may have seen before, but this is the video taken on one very stormy day from the permanent pasture paddock at Northwick. And this is the one of the field we were having the resident grazing at the Northwick Farm platform. And this is only 200 yards away, and the video was taken only 3 minutes apart, and you will see very different color of the water and turbidity. And from the this is the arable field that we had converted and from the permanent pasture. So in the context of Ian's question about the carbon loss and the nitrogen loss, and there is a huge change in dynamics of the nutrient flow. This is just one storm event, and from the late autumn, that And then the quantity, the graph you're seeing is the amount of the soil we lost from the converted arborland and the original permanent pasture. And then we quantify the amount of the soil dried, and the actual difference was about the factor of 7. So the point here is that you try to convert land to a more sustainable system. Maybe that's a benevolent change that the people propose, but ultimately you may actually not have any soil at all to produce food to begin with. So the point here again is that and when you talk about, and pretty much what Ian is suggesting on the just screen, but when you convert land use, then that means that you have to really think about what will happen long term as well as the short term. Again, so that's the question about the at what time scale you want to achieve net zero, at what cost, and the because if you try to achieve a short term without much debate on the insight, there's an element of emergency, and we have to acknowledge, and therefore, you cannot keep saying that we should discuss, but it's a matter of balance between the speed versus the regret you may have from long-term, very large unintended consequences. So, with that note of the general idea about net zero, I'd like to go a bit more into the specifics of the methane gases. So you probably are all aware that so in agriculture, there are three important greenhouse gases that are CO2, carbon dioxide, N2O, nitrous oxide, and methane stage 4. And unlike the CO2 and the nitrous oxide, methane is short-lived. And you are now seeing that how the warming potential of each gas differs. And when you focus on methane, then the years after pulse, the time whereby the vast majority of the gas stays in the atmosphere is much, much shorter. That means that its effect on the temperature on the global temperature is not entirely cumulative, because some of them will disappear, and unlike the CO2 and N2O, of which stay in the atmosphere is so long that in the current they do eventually disappear. But in the current context of the net zero and in light of the urgency to resolve it, we can largely assume that they will be there forever, say over the next 200 to 300 years. So methane will be accumulated into the atmosphere and after each season of the farming system. But then once you hit a certain point, then the old methane will be replaced by the new methane. So that means that if the amount of emission every year is unchanged, then that means that the amount of methane in the atmosphere is largely unchanged. It's not completely, I will explain that in a minute. So this year's contribution to climate change is all these recent emissions of methane gases, as opposed to cumulative historic emissions of the methane gases. You probably are all aware of that in this group I take it. But what it means is that you have to separate the temperature effect of methane from the temperature effect on other two gases. And here comes the concept of GWP star, which is known to represent this phenomenon better compared to the global warming potential 100, which is the indicator of the average radiating forces over the 100 years. But it is not an inaccurate metric. It accurately estimates the radiating forces over the 100 years, but that does not mean that it predicts the temperature change directly. This graph proves this point, and here the actual temperature change is shown by the broken line, And you are seeing that the blue curve, the GWP 100, goes off the mark after say 20 years. So that means that the radiating forces there are not the right indicator, right predictor of the temperature change, whereas the purple curve, which is the GWP star, matches really well against the actual temperature as predicted by the physics model. So that means that if we assume that our main concern in the context of the climate change is temperature change, which probably the vast majority of us can agree upon, then the GWP star is probably a better indicator to predict the change in temperature in the future. Now, this has led to quite a common misinterpretation that methane is short-lived and therefore its emissions do not matter. This is incorrect. And of course, we are part of the livestock industry, and we want to understand and defend the industry in the right way to change the course of the industry to a more sustainable way. But if this misinterpretation persists, my take is that it will not happen because this is scientifically incorrect. And I'd like to explain why it is not correct. And there are roughly the four different reasons for it. The first point is about the long-term equilibration. So there are when you talk about the temperature impact of the methane, then there are two different distinct impacts. One is called rate term, and the rate term is the short-term climatic response to changing the radiative forcing. And this is actually zero at the constant emission rate. So that means that this term, rate term, can be ignored if we will only constantly emit the methane at the same rate. However, there is another term called stock term, which is the result of long-term equilibration to a change in the radiative forcing, meaning that the atmosphere has not reached the stable point yet because of our changes in the emissions. And this is not attributable to today's emissions, but the recent sudden increase in the methane emissions by human beings. And this effect is known not to disappear with time in the short run. And loosely speaking, this stock term is about 6% of the overall methane emissions. And so essentially, even after, say, 20, 25 years, where GWP star assumes that methane will no longer be in the atmosphere in the main, and this effect will always stay there. GWP star equations do account for it. But when these equations are translated into plain English, it is very rarely mentioned, and therefore many people misunderstand that this term doesn't exist. So the graph you are seeing here, so after 20 years, and the vast majority of the emissions will be gone. However, you are seeing that the graph doesn't go down to zero, but about like say the 10% or a bit less of the actual emissions. The second reason why methane still matters is more nuanced, more political potentially or philosophical. And it is about the responsibility of or who takes the responsibility for the past emissions. So suppose that you argue that this year's livestock methane emissions do not lead to a further increase in temperature. And that is only because the same industry emitted methane in the past. The reason why you cannot you cannot, you don't increase the methane in the atmosphere is purely because you emitted more in the past. Now, whose fault is it? Is a very, very complicated political and societal philosophical question. But can we claim the ownership for these emissions as the industry? Meaning that is that the industry's fault, or is that more collectively the societal fault? Because or societal fault or needs, shall I say? Because that industry was necessary for the economy and the economic development. And depending on your take, if the industry has to bear some responsibility for the past emissions, then that means that you cannot really say that we are not polluting anymore, because that's entirely owing to the past emission. So this nuanced part of the debate has to be acknowledged. Maybe the right answer is that past emissions are to meet societal need, in which case it's not the industry's fault. But either which way, and this has to be acknowledged, otherwise you're ignoring the evolution or the evolvement of the industry and just saying that, pretending as if nothing happened. Maria, is there any indication that the IPCC is seriously looking at GWP star instead of GWP? Yeah, that's 100%. So the latest report in 2021 indicated that this was the method to be considered as well. And the IPCC does not recommend one particular impact assessment method over others, but this good correlation between the actual modeled temperature change and the metrics of the GWP star as opposed to GWP 100 is already acknowledged. So I cannot say that it will overtake the current standing of the GWP 100 immediately, but the common understanding is that the scientific community is moving towards that direction, and then it will be acknowledged much, much more from here onwards. And as I said, GWP 100 is not wrong. It is a wrong indicator of temperature change. And temperature is probably the most important metric of climate change that we have to focus on as in our global effort. But there are others, for example, extreme events, for example, storm, flood, and drought, and overall change in rainfall and so on. So GWP star is not known to be good predictors of these other consequences of climate change. And so we are looking into GWP star thinking that the climate change, sorry, the temperature change is the most important metric to focus on. But I just wanted to give that caveat as well. So on the past emissions about the starting point 100%, is that dawn of agriculture or the sense of starting point being total number of wild animals, now largely replaced by the domesticated animals? Yeah, 100%. I think, again, this is a political question, and we shouldn't really answer as from the science and this question. But loosely speaking, the concept of this past emission is the domestication of animals. Basically, that's the definition of the anthropogenic emissions attributable to human activities that do not have happened without our economic activity. And so yes, and your final sentence is probably spot on about the replacement or complementarity between the domesticated animals and the wild animals from one point in the history when domesticated animal exponentially increased the importance in the society and economy. And the third point is about the NT1 CO2 emissions that accompany methane emissions. So let's forget for a moment about the stock rate, meaning that you assume that the long-term methane impact is zero. As I said, it's wrong by 6%, but put that aside for a minute. But methane does not matter, does not mean that livestock emissions do not matter. And livestock emissions do include NT1 CO2. And depending on what kind of farming systems you are looking at, methane is important, usually the most important for ruminants. But in Northern Ireland, 30% of the agriculture emissions, and maybe across the UK, about 40% of agriculture emissions are non-methane. And the value is lower in Northern Ireland compared to the rest of the UK because we have got more heavier reliance on grassland agriculture, meaning that the methane is the more important because the NTO gets emitted more from the soil when you apply the fertilizer. And but put that aside, there is no such farming system whereby you only can emit methane. And therefore, usually the fact that methane emissions occur means that the NT1 CO2 will come out as well. So therefore, okay, maybe methane doesn't matter. And even so, that doesn't mean that that system does not emit the greenhouse gases. And the other two gases, as I mentioned, will stay in the atmosphere for a long, long time to come. So you still have to mitigate all these things because they come together. Possible ruminant population figures are much less certain than often quoted. That's 100%, I agree with that. And there are many, many models to estimate what humans did to the ecosystems as opposed to what would have happened even without us anyway. And there were a certain level of confidence about it in the past, but the uncertainty is now getting more exposed, I suppose, in the literature. So yes, what I said was philosophically probably correct, but the how to really define the past emissions is not that straightforward. I completely agree with you that, and with you, Ian, on that. The final point is that weirdly, the methane is the only pathway to achieve short-term net zero without land use change, meaning that without the another form of the carbon capture to offset the greenhouse gas emissions. So why methane still matters? So you are looking at the offset in the future, and once you emit CO2 and NTO, there is no way to offset them within the foreseeable future. Whereas methane, you can change the course of your action, sometimes past action as well, and then can contribute to global cooling or the remedy to the current trend in climate change. So this is the new recent modeling results from the Rosamset team. I work with the Graham on that. And what you're looking here is that what should we really mitigate to change the temperature effect or the reverse the temperature effect. The vertical axis here is the CO2 warming equivalent, which is essentially the predicted change in the temperature in the future. And as you can see here, if you want to prevent the short-term temperature increase, then what you should do now is to mitigate methane. Because if you mitigate methane, and if the replacing methane is less in quantity than the replaced methane, then you can immediately contribute to the temperature change. to be very fair, we cannot drastically reduce the temperature as a UK farming sector because in the context of global agriculture, we are a very small player. But you cannot really start saying that, and then therefore you don't have to do anything because if everyone says that, then nothing will happen. So and this is probably not a practically drastic solution, but in theory, you can contribute to the global cooling here. However, to prevent long-term temperature increase more, what you should do now is to actually mitigate N2O rather than methane if it's one or the other. In reality, it can be both, but in an extreme question of whether you should do either or, you should actually work on the N2O more, because as you say, as you can see here, the impact of the N2O mitigation will become bigger compared to the methane because they will disappear anyway after a while, except for the 6%. So that's the kind of the short-term, long-term quandary here that we have to also think about, depending on what kind of target you want to set. Slurry is a new source of methane data. No, and so that's an interesting question. But stock term and rate term applies to any kind of methane emissions. If maybe I didn't explain it very well, but if you emit a portion of methane, amount of methane into the atmosphere, you always have got both stock term and rate term. So it doesn't matter how it is emitted. Once you emit it, you have got both. You always have got the 6% accompanying the rest of the rate term. So where it comes from doesn't matter. Yes, however, I do agree that the slurry is a new source of methane. So yeah, that's the irrelevant to the wild animal age. It's a diversity question from Susanna. So to what extent can the emissions be can be an excuse? I take it that the question concerns the grassland-based agriculture. And yes, so in terms of the biodiversity, that's 100%. Yes, grassland and agriculture, especially on the diverse soil agriculture, perhaps have got the much, probably relatively speaking, better effect on the biodiversity, or maybe you can minimize the negative impact compared to when the land is not used at all for food production. But I do agree that that doesn't really mimic the wild place. But then again, if every single piece of land is is wild or the wild as per the old age, then that means that we have no food to eat either. So my take personally is that this minimal impact on biodiversity and probably a less extent the water quality, less extent because that can be more preventable, and should be excused in the context of the macroeconomic debate. You cannot really have zero impact on biodiversity when you want to use the land-based agriculture. When you don't use land-based agriculture at all, that means that you probably are talking about vertical agriculture and so on. But that's not enough to feed the population and the current technology. And even in the future technology, to do that without any reliant on additional energy, meaning that you only use the carbon neutral energy, and that will be a huge challenge as well. So whether it is excused or not, again, it's a political question. But I think my personal take is that all things considered, to minimize the negative impact, that form of agriculture is probably the most excusable form, and you cannot really avoid that in the short term. Stock price is that time that you couldn't take away. Okay. Would any methane production organism be contributed to everlasting? No. So this stock term gets the amplified when there is a sudden change in the emission rate across the world. And then obviously we don't know what happened like millions of years ago, but within our reasonable the time frame, this has only started when we started the industrialization of both agriculture and the other industry. So just because you are emitting methane, it doesn't have the large stock term. Large stock term occurs only when there is a sudden increase in the past, in the immediate past. And we are living in that strange time when that happens, say 20, 30 years ago. So I think I already explained, but of course you can artificially remove NTO and the CO2, or you can sequester carbon elsewhere. But that requires the other solution, probably land-based solution, whereby you need to convert some of the farmland. That again leads to an impact on the food security or the food production. On the other hand, methane reduction can result in global cooling effect, and that is basically the only way to whereby you can achieve the short-term net zero without converting the farmland to other land use. Whether that needs to happen or you can convert part of the land, and that's another debate. But here, basically, that's the only option if you are to keep the full amount of the grassland for livestock production. So that's basically the uh, uh, more theoretical basis for the net zero GWP star debate. Now, more practically speaking, then, on how should we see that? And I'd like to share some of the modeling results from the Northern Ireland, the policy discussion. So, and you may be aware of our net zero and livestock report commissioned by CL in 2021. And that report lists the combination of 14 currently available greenhouse gas mitigation technologies across the UK. And we estimated thereby that if you combine them all, then we can probably reduce the CO2 equivalent and emitted per year by about the 8.2 gigaton. And about 50%, a little bit more of that, would come from methane reduction, others from CO2 and the N2O. Now, if you do that all, if we apply all these unavailable technologies on all farms across the UK, and this is a big if on many fronts, I'll get to that in a minute. But if you do that, then our modeling suggests that the global cooling effect from removing about the 4.1 gigaton of the methane from the atmosphere is larger than the global warming effect of continuing to emit CO2 and N2O even after mitigation. Mitigation will, thank you very much, Nikki, and share the link to our report listing the all the mitigation technologies there. But even with mitigation, you always have got the warming impact of CO2 and N2O. But for methane, if you mitigate enough so that the replacing methane is less than replaced methane, then you can lead to a global cooling effect. And we identified, as you can see on the bottom left, that if you implement all of them, then the global cooling effect from methane reduction is larger than the global warming effect from the CO2 and N2 emissions. So I said earlier that this may not be enough because we may be responsible for the past emissions. But put aside that discussion for a minute, this is a very positive finding for the industry, because that means that at least from today onwards, if we work hard to implement all these mitigation technologies, there will be no additional contribution to climate change from the livestock sector, because everything is cancelled out by the reduction of the methane across time. There is a catch though. The catch is that this happens only in years when the reduction happens between now and say 20 years ago. The whole point is to reduce the amount of methane within the atmosphere. So this statement will no longer be true once the old methanes are all gone, and therefore all the methanes in the atmosphere are, as a result, post-mitigation. So that means that, say, in 20 years' time, you have to come up with maybe another 14 mitigation strategies to further reduce the greenhouse gases and from the emissions from the livestock sector. So you cannot just keep doing the same thing over and over again. That will never, because then the amount of methane will always be the same in the atmosphere, and therefore you will always have got the global warming effect from the CO2 and N2O. But what it does do is to buy us 20 years of time to work on the mitigation strategy and also maybe sequestration strategy. And the livestock market may be different at that time. So rather than doing nothing, if you work on this, then there is potentially a very good outlook for the industry. So that's the finding. We also found that the amount of the negative temperature effect for the next, say, 20 years is quite large. Therefore, we try to back calculate on how much actually reduction is needed. This matters because the assumption that all farms across the UK will adopt all the mitigation strategies is quite unrealistic. And also there's a cost implication of that. So here, again, we are doing this and the mitigation at any cost approach, under any cost approach, whereas in reality, we cannot do that. So how much would be required is something we also want to try to understand. Exactly, yes. So Ian's point, and it's pretty much what I just said. So this is more an technical exercise to understand whether it is mathematically feasible and for the industry not to contribute to climate change. And our view is that it is. But whether it is economically feasible and economically most sensible is a different matter. So to back calculate purely for the Northern Ireland, but the probably the results are quantitatively not the same but comparable. And we identify that for the methane mitigation effect for the next 20 to 25 years, and to be enough to offset all the greenhouse gas emissions in the form of CO2 and N2O, we quantify that the about 15% mitigation of methane will be required from the Northern Irish livestock sectors. So that means that once you achieve that, no short-term incremental temperature effect will happen until the end of those 2025 year period. If you work on N2O emissions, for example, N2O soil inhibitors, at the same time, then the even less effort would be required because the amount of N2O to offset would be less. So, and this could be potentially about the 12% of the mitigation of methane from the livestock sector. 20% and 50%, it may sound small difference, but it does matter because depending on what kind of methane inhibitors we are looking at and what kind of the management change we're looking at, for example, in terms of the slaughter age, the threshold could be 12%, threshold could be 15%, depending on the technology and also the uncertainty analysis you run out. So that means that the value of 15%, depending on the technologies and depending on which studies you look at, is probably within the feasible range and the within potentially economically feasible range as well. But if you can reduce that to 12%, 11%, it's even more feasible because there are much wider options of technologies, mitigation or inhibition technology, and that's available. So that's why, again, NTO mitigation is also important to reduce the target and therefore make the methane mitigation more easily achievable. Yes, absolutely. So the yes, the industries, and the carbon strategy, and that's probably and something we can probably discuss later. But yes, I agree that there has to be a strategy there as opposed to just buying into the tunnel vision. Yeah, I fully agree with that. So and so that's the target, and therefore you are, if you buy into it. And depending on the cost implications, I understand that. And the industry can have no short-term impact, put aside the past. And that itself is quite a positive outlook if you put your mind to it. It's not really well understood. And the last but not least, we have been talking about the greenhouse gas mitigation until now, but there are also the question about the greenhouse gas adaptation. And at API, we are working on how to prepare ourselves for the different climate. And who created this climate change or will create this climate change is neither here nor there. The chances are that the climate will be different. And we are looking into the how the gross production system has to be designed to make it future-proof. What you're looking at is the computer simulation we built to estimate how much grass would be produced, would have been produced in the past where we don't have data, and would be produced in the future after the climate change. And we are probably looking at between now and the 2100, we are probably looking at the increase in about 3 to 3.5 tons of the dry matter production. Although there are some uncertainties here about the change in the the seasonality of the growth. I think that in the vast majority of the simulation runs, we are seeing an increase in the season rather than the increase in production at the height of summer. So that means that we have got higher production in, say, April, May, and also on late August to September. Bear in mind that the Northern Ireland is probably slightly colder than the vast majority of where you live. And therefore, there may be some implications on the forage quality. So we don't know whether we are to be able to maintain the same level of the protein content and also the same level of the fiber, cellulose and content of the grass. But we are looking into the solution, and so that we know what kind of salt mixes would be the best suited, probably within the time frame of the 30 to 40 years. But the point here is that the productivity itself, at least if you nominally measure that by annual growth, is most likely be higher there is the opportunity here for the industry and to create the better system. And by doing so, you might be able to set aside some of the land without reducing the stocking rate, unless you choose to increase the stock and so that you can produce more food. And I think that would be a mix of both, and depending on the market demand and also your own management strategy. But the point is that there are opportunities if you are looking enough, and we try to achieve that by combination of the modeling and field trials, but also the breeding strategies. Yes, so the yield predictions based on the perennial ryegrass. What you are looking at is the perennial ryegrass. So we are looking at the clover, we are looking at the multi-species as well. But what you're looking at, this graph is the perennial ryegrass, and as you probably know, our models are always most accurate with the perennial ryegrass because they are less and degree of uncertainty. Artificial nitrogen, yes, applied. We have got the version of the organic version. We also have got the version of no fertilizer, but for what you're looking at, artificial nitrogen is applied. What does that do for mitigating N2O and CO2? What does that do? Bill, could you type what this means in the context of this modeling, or?
Yeah, just that obviously most of the nitrous oxide comes from application of nitrogen fertilizers, but there's also the CO2 that is embedded in those fertilizers from the manufacturer. And so this model that you've shown us here looks as though that would have some very adverse implications for those other two gases.
Yeah, sure. No, spot on. So we have got the carbon model behind this and the prediction model. What you're looking at is just purely the biophysical production from the grass systems. But the we are applying the N2O inhibitor there, and the for CO2. Our model sometimes assumes the renewable energy for the electricity. Diesel, we are at the moment still using it, but and hopefully we will be able to change that to renewable and the fuel as well.
Right, thanks, Taro. I didn't mean to interrupt.
Yeah, thank you so much. Thank you so much, Ian, and and for all your engagement as well. And just to wrap up, so these are the take-home messages. You probably have got the already everything, maybe too much, but the net zero is always possible if you don't need to produce food, and that's very obvious. I understand that, but very seldom discussed explicitly. Methane still matters in the context of climate change for a number of reasons, 4 I mentioned, but probably more. If you implement everything existing mitigation measures, that is more than sufficient to prevent further climate change short term from livestock farming. You have to do, everyone has to do everything, and that has got cost implications. And even then, past emissions cannot be reversed. But at least you don't contribute to further climate change from here onwards. And in terms of just offsetting it, like even reducing a small proportion of methane, I mentioned the value of maybe 11, 12, or 15%, could reverse the future of the livestock industry. And that could send a very positive message, especially in the context of the outdoor-based agriculture, where methane emissions are proportionally higher compared to other sources of the greenhouse gases. And of course, outdoor means that you have got, as someone, maybe Suzanne mentioned, you are able to slightly more mimic the wild system. So that means that there is less biodiversity impact as well, but I'm sure you already know that. So on that note, I stop my presentation, but thank you so much for your engagement, also the in-text questions. But if you have more questions, I'm more than happy to answer. Thank you so much.
Oh, brilliant, Taro. Thank you so much. I've got a couple of questions. Yeah, I'm sure others will have other questions that they want to ask now you've finished. So thank you ever so much. Really, really interesting and so useful to put so much kind of more context to the methane question. So really appreciate that. The two things I want to touch on. One is the very first slide almost that you had about one cow needing to be sort of offset, if you like, by half a hectare of trees. And I was talking to your ex-colleague Laura Cardenas a couple of weeks ago down at Northwick, and we were talking about, a cow at grass, and John Francis Susanna, who's I think in France, has done some work on this, and that's kind of been debunked by Pete Smith and others. But this idea that we only think about trees as being able to offset cattle, for me, is bizarre when we have cows kind of out at grass, and that grass is obviously doing a job to cycle in the carbon cycle. So there was a question there about kind of, how taking into account grasses and grass-based systems, and I totally get that there is so much risk of emissions from grasslands through bad management as well. But if we think about pasture for life farmers, where grassland management is potentially, like, it is the most important thing on their farm system, because that's what they're relying entirely upon for their forage and for all of their feed, then there's something there that I think bears potential further exploration. And then just thinking more about the pasture for life system, I was looking at reminding myself, actually, because I remember looking at it before, the CL emissions fact sheets that have been produced as a result of that report. And when we look at them, for example, for beef, it talks about feed. Well, all of the things to reduce emissions from feed aren't relevant, obviously, for our farms, or our certified farms at least. And also the manure fertilizer, I would say that none of those are really relevant. I don't think any of our beef farms, I would feel very confident to say, I don't think any of our beef farms are having to manage slurry. They may well be managing farmyard manure, but it's not slurry. And we have an increasing number of farms that are managing outwintered systems with constant movement. So it's not like there's not a direct deposition of a huge amount of manure on a feed pad. These animals are moving across the landscape, and it's basically the same as in summer, but just during the winter. And so, yeah, I'm going to stop there. But just kind of this idea, and actually, sorry, no, just to say, on that fact sheet, it says the greenhouse gas emission intensity of UK produced beef is 48 kilos of CO2. It's not been published yet, but I'm sure Nina doesn't mind me saying that in an LCA that was done from one of our member farms this year, it was 21 kilos. And so actually our farm systems already are kind of, more than half that of the number bits that's been used there, which feels like we need more research around these sorts of systems. But yeah, are you able to kind of touch on that, why always trees and not grass in terms of the offset, and how are we better able to represent these much lower input systems within these, for example, when presented with fact sheets like this?
So we did discuss that internally, and that example, we decided to use 3 because there is carbon sequestration is full of uncertainty. Whatever measure you use, you really don't have the very accurate value with any level of confidence, really. However, we came to the tentative conclusion that by converting land to forest, you have got less chance that you cannot sequester additional carbon at all. Okay. Whereas if you maintain permanent pasture as permanent pasture, then there is a chance, as you probably know, that the soil is already saturated with carbon. And so that means that even no matter how well you manage, there may not be any room for the soil to sequester more carbon there. If you are receding, which is much more common in Northern Ireland, when I was back in Devon, probably some farmers and had got the permanent pasture not ploughed at all. But then if you recede, then no matter how much carbon you sequester, chances are you release a large amount of that, large portion of that when you recede by ploughing up. If you don't plough, then there may be some chance, but then again, you have got the satiation risk there. So we were not confident enough to say that by maintaining good grassland as good grassland, you can offset the enough carbon emissions from a cow. And so that's why we chose to be on the safe side, to not to send the wrong message.
Brilliant, thank you.
Bill,
Bill, do you want to come in?
You're mute.
What worries a lot of us, I think, Taro, is that the calculations are based on evidence that doesn't come from the kind of situations that we all work with. So if we look in the literature, there are very few studies actually measuring emissions from systems like ours, and they just use the standard metrics. So, but where there is evidence from actual sites with flux towers or with fixed chambers, then they suggest that they're even on old grasslands, permanent pastures established for generations, there still seems to be a net sink for carbon. And there's one very particular study that took place not far from where we are in northern England, showing that two grasslands were absorbing in the region of 20 tons of carbon a year. But that evidence never seems to get any traction, and it worries us. The other thing is, of course, that nobody is measuring the methane actually emitted from the animals that are grazing these situations. You know, it's all done from these boxes in a more laboratory kind of setting, and so we need the evidence to show what is actually happening in the real world that we're all working in.
100%. We need more evidence to, for example, be able to show that the methane emissions are much lower than currently suggested by emission factors. So and you're spot on. In the grazing condition, we have got much smaller set of data to basically quantify that. We tried that once at Northwick to place green feed on the permanent pasture, but we were not able to do that very well because the animals congregated around that machine, which dispenses the sugar beet and the other basically yummy food, and then they poached on the basically the area. Poaching itself was an issue, but the bigger issue was that it changed the cattle behavior, and therefore you cannot really measure the methane emissions in a grazing condition as such. So it was a particularly with someone we had to give up. Now at Api, where I moved, we are measuring the methane emissions from grazing animals throughout the summer to create more evidence base. And so basically, just you said, we also have got the closed chambers system, and we want to know how the values should differ across the season when they are in happier mindset and healthier condition and the better fed with the natural and the forage. So that's what we are working on. In terms of the carbon sequestration, I am aware of the flux tower studies whereby they seem to have shown that the carbon stock improved even after decades of the permanent pasture management. But I don't think that is universally true, and therefore, coming back to Nikki's question, we were not confident enough to say that, oh, you have got a cow, but if you have got a permanent pasture, then you can offset. However, in Northern Ireland, we are now measuring the carbon stock of every single farm. This is the project funded by Department of Agriculture here. And the plan is to go back to all farms every 3 to 4 years to track the basically the accumulation of the carbon. to be fair, it's easier to do that in Northern Ireland because the area is small, and therefore and the logistical, there are much less logistical issues of doing it. But I think to generate evidence in this manner, especially in the context of infrequently receded the grassland, is really important. I completely agree with you, and we are working on that too.
Would it be all right if I sent you some information that we have that is relevant to this discussion, and perhaps you could give me your opinion on it?
Yeah, sure.
Great.
Thanks, Bill. And also just to add to that, Taro, we're working here with Scotty ID, who do all of the livestock tracking in Scotland. They're building some methane sensing equipment for us to use at pasture. So we did submit an Innovate UK bid, but unfortunately, for whatever reason, we weren't successful. We were going to also make the data open source, which would have made it much more useful than Greenfeed, which obviously has a huge cost attributed to it. But yeah, once we start getting those up and running, it would be good to kind of share some of that with you and others around, just to get some academic feedback. I'm conscious of time. We've only got 12 minutes left. So Catherine, your question, then we'll go to Nick, then Jimmy.
Yeah, hi. Thank you, Nikki. Thanks, Taro. That was a really interesting presentation. I'm just going to go slightly back to your answer to Nikki's question, and you know, explaining why, for the sort of the reliability of your research, that you decided to use trees rather than looking at grass as the sort of offset factor. And I just wonder, it's just a question for you really, as to whether you think that there is a problem that arises around these sort of making assumptions about the capacity of grasslands, overlooking those assumptions, because to some extent in papers, maybe is there enough effort put into actually setting out what the limitations were, you know, in terms of saying actually explicitly that you're not discounting grasslands as being that sink, but that for these reasons, you know, you felt it was cleaner to use trees. Because I think sometimes, without being explicit about those things, perhaps, you know, that's not understood by the reading audience, research and more broadly.
Yeah, sure. I think it can go both ways. So on the one hand, we don't want to basically say a lie, and so we try to avoid this grass sequestration discussion. If you say that the grass can offset, then you can get caught there, and we're worried about that. But on the other hand, if you don't mention that at all, then you just said, you're spot on, that you could send a wrong message. Oh, we have to actually plant trees, and when that may not be necessarily the case. And that's why we decided to measure the carbon stock of all the farms in Northern Ireland. But also, I think it's also that not all farms have to do the same thing. Some farms are probably more suitable for agroforestry, for example, because of their topography, and then you may be able to mix them both. But some farms, because of the undulation and because of the soil structure, maybe to keep grass as grass is a better option. Yeah, so we do discuss this internally. We do talk with communication specialists about how to get by, but we haven't really come up with the settled strategy yet. But I fully accept what you said.
Thank you. Nick.
Hi, Taro. Yeah, thanks for a really interesting talk. It's, yeah, fascinating. GWP star, it's obviously got a lot of benefits and such, but do you think that there's quite a lot of risks about potentially global cooling and maybe transferring some of our livestock industry abroad to try and kind of make quick gains if you kind of skew statistics in the way of, you know, cooling and net zero? And also, do do you think that there's risks with countries that don't have such a big livestock industry or a history of red meat consumption being particularly negatively impacted by this and a lack of historic emissions?
Yeah, absolutely. I think the first point of the question, we are reasonably confident about the model results, assuming that our assumptions are valid. However, what we are extremely worried about was that the results being taken out of context, especially the part that, you know, this is a very temporary solution, in that after 20-25 years, if your atmosphere is unsaturated with the current methane, then you have to keep reducing it. So this will be probably forgotten, and it would be reported. I can picture that the current mitigation strategies are fine, kind of thing. So, and also, as you said, it depends on the history of the red meat and the dairy sectors of that particular country. And I think the message here would be probably quite bespoke for the British history and the British context, and then how this would go into, like, for example, newer continents, but also low-income countries. I think in terms of communication strategies, we have to be extremely careful about yeah, if that's what you are getting at. Yeah, that's
Yeah,
definitely.
yeah,
Yeah. That's really, really nice to actually hear, because we kind of know it, but we have never been told and outright. That's really useful. Thank you.
Cheers.
Thanks, Nick. Jimmy.
Thank you, Taro. That was brilliant, and great to get you into this group as well. We've all been talking about you for many, many years, and it's wonderful to have you here. My point is, I suppose, picks up on what a lot of other people have been saying, and my slightly tongue-in-cheek planned obsolescence comment in the chat, which is that I suppose a lot of the research, to me, and I suppose a lot of what you've presented, seems to have at its starting point the fact that agriculture is harmful when you compare it to nature. And I suppose, thinking about a UK context, perhaps the climaxed community of woodland is the kind of ideal point at which we need to be comparing to. And I suppose for me, that is, as partly as you've highlighted, that feels quite political. And I think particularly in this kind of climate change, land use, biodiversity kind of space, there are some scientists being quite political. There are some scientists trying to avoid being political, but in my view, you can't really avoid the fact that it's all political. And I think what we're trying to do at Pasture for Life is move away from describing farming within that framing of harm, which I think if farming sits in that space, there's only one way it's going to go, which is that we will all be eating a daily pill for our nutritional needs. And if farming is harm, we need to be avoiding harm, and that's just the direction of travel. I think what we're trying to do, which is why it's so frustrating that there's a lack of data, and I suppose sometimes what it feels like that there's a lack of interest in these sorts of systems from researchers, is actually tell a very positive story about the kind of harmonious interactions between humans, nature, and for the production of food. And so I guess my question to you is, why have we not got more researchers focusing on that? Why is the research seemingly focusing on the avoidance of harm when it could be focusing on the many positive things that this interaction can be giving humanity?
That's a really, really good question. And I don't have a perfect answer, but I do have a thought, so I'll share that. First of all, about the climax community, that's 100% spot on. So and I completely disagree with the view that the society has to have a climate community as the benchmark or the baseline, because we simply cannot have it. So we probably would have been able to reach a closer state to that when the population density was much lower. But with the current population density, we cannot achieve climate community. And therefore, to call it a utopia does not solve anything. The fact is we have to eat. And the fact is that we cannot drastically reduce the human population. Maybe that's the desirable thing to do anyway. So we have to accept the current population as is, and then we have to think about what would be, what should be done. So to me, starting from the climate community is entirely meaningless, and I 100% share your frustration there. So then what should we do? I think what we should do is to start with the desirable land use, which means that the least harm possible, and which is replacement of the climate community. And then you look at all the positive things that you can do within that rule of engagement. Now, why have we been so negative in the scientific community rather than positive about all the services you can bring to the society, whilst also serving people with food? I think that's, I don't know, to be honest, that's a really difficult question. And I don't think there's anyone who can confidently answer in the world. But my personal take is that that's because of the historic context. So I think the scientific community has been much more responsive rather than proactive. And then since probably the maybe 70s, maybe 80s, when we started sensing the sign of the large-scale environmental change, the community panicked, and therefore they tried to basically reverse it as opposed to accept it and then see the positive side of all the services. And so I think that's largely due to historic context of the environmental research, and we learn under supervisor, and we become supervisor, and we teach students. So there's a gradual generational change, but that wasn't fast enough. And that's where we are, I think. What should we do on that? I think the understanding of the climate community, the discounting of the climate community is probably one of the most important things. And then that's probably a very highly philosophical level. But what I think and what I keep saying to my institute and the NI government is that the no discussion should start from the target in terms of the food production from a particular area. So for example, in the NI context, we have to say that this is the production target we really have to meet, because otherwise macroeconomy will just suffer or the unemployment rate would be too high. Within that rule of engagement, and how much the ecosystem service can we provide? How much of the pollution we really have to incur, and then how can we offset? But again, going back to my very first slides, this net zero debate and sustainability debate was basically about net zero sustainability at any cost, but there is no such thing. You have to produce food. So where do we start that debate? And that starting point has been really off. That's my personal take. It's partly my fault, our collective fault as the scientific community. So it's not like I'm criticizing anyone, but that's something we should be more conscious about. I'm not sure if I have answered sufficiently to your frustration, but.
That was great. Thank you. Thank you, Taro.
Thanks, Taro. And I think, you know, we say this to everybody who comes to speak to us, but we really do mean it when we say that if you're able to access funding or interested in collaborating on undertaking research that looks at the sorts of systems that we are working in every day, then we will absolutely find farms for you to visit. We will produce case studies. We will be able to, you know, deliver anything that you need in order to explore the sorts of systems that we are advocating. and Nina and Nick have been working with us in their roles at Reading to do that, and we're always keen to do more of it. So, and we do have some certified farms in Northern Ireland as well. So, you know, please do let us know if there's anything that we can contribute to the discussion. I'm conscious of time, we're 1 minute over, and I always try and keep us to time, so we will stop there. I'm so grateful that you're able to join us this afternoon. It's been an absolutely brilliant session, and I will circulate the recording to just the this membership group, but I definitely want to watch it back when I'm feeling quite tired today and I feel like I need to watch it back and pay better attention than I possibly did. So Taro, thank you so much. Thanks again everybody else for coming along and joining, and your excellent questions as always, and yeah, hopefully we will catch up with you at some point in the future. Take care everybody, have a lovely weekend.
Thank you very much.
Thank you.
Thank you, Taro. Thank you, Taro. Yeah.